So, if you're a Go developer, you've definitely run into the context package, right? But there's this one little feature inside it, context.withValue, that, oh boy, can get you into some serious trouble. It's the kind of thing that can turn your beautiful, clean code into a total house of cards. So today, we're going to pull back the curtain on this super common anti-pattern and, more importantly, figure out how to avoid it.
Okay, check this out. You have turned the context into a magic bag. Wow, that's a pretty strong statement from a senior engineer, right? This magic bag thing, what does it even mean? Well, it's all about hiding your dependencies where they just don't belong, creating these invisible landmines that are just waiting to blow up your application. So the big question is, how do so many developers fall into this trap in the first place?
All right, let's talk about a problem I'm pretty sure every single one of us has faced. You know the drill. You start with a nice, simple function, but then it needs a database connection, and then a logger, and maybe some config details. And before you know it, bam! Your function signature is a mile long and just a total mess to work with.
So, let's meet our protagonist, Ethan. He's a junior dev, he's working on a billing service, and he is staring right at this exact problem. His functions need to talk to the database, they need a logger, and they need to know the ID of the user they're charging. He's looking at this mess and he's thinking, there has to be a better way. And then, he thinks he's found the perfect tool for the job.
And that tool is context.withValue. Now, from Ethan's point of view, this looks like a stroke of genius. Why on earth would you pass all that stuff as arguments when you can just, stuff it all into the context? I mean, the context is already getting passed around everywhere for things like cancellation and deadlines. It just seems so elegant, so clean.
And you can't blame him, right? His goal is totally understandable. He's chasing that developer dream, a super short, simple, clean function signature.
And voila, this is what he ends up with. Just look at that. Charge customer now looks like it only needs a context and an amount. It's so tidy, so simple. All those other messy dependencies, the database, the logger, the user ID, they're all just tucked away, hidden inside that CTX variable. But, and this is a big but, as we're about to find out, what's hidden can be incredibly dangerous.
Okay, so this is where Eleanor, our senior engineer, comes back into the picture. She takes one look at Ethan's super clean code and immediately sees the red flags. She recognizes it for what it is, a classic anti-pattern. And she explains that by hiding all those dependencies, he's basically thrown away one of the most powerful tools Go gives you, the compiler.
And Eleanor just nails the problem with this line. A function signature is a contract. Think about that. It's a promise. It's supposed to tell any other developer, or, you in 6 months, exactly what this function needs to do its job. And Ethan's function signature? Well, it's lying. It's promising it only needs a context and a number, but that is absolutely not the truth.
So what happens when that contract lies? What happens when that promise is broken? Well, things start to fall apart, and they fall apart fast. The very system that's built to protect you, the Go compiler, is now completely blind, and you're left to discover the bug at the absolute worst time. You guessed it, when your app is already crashing in production.
And this is the real price you pay. You're trading a clear, easy-to-fix compile time error for mysterious, late-night runtime panic. The compiler can't warn you that you forgot to pass the database connection. Nope, your code just panics. It makes it impossible to see what the function actually needs, which turns unit testing into a frustrating guessing game and basically leaves the next poor developer to inherit your code completely in the dark. But okay, enough doom and gloom. Fortunately, there is a much, much better way to handle this in Go. It's a standard, safe, and professional pattern called dependency injection. And really, it's all about one thing: being explicit and honest in your code.
So what is dependency injection? It's simpler than it sounds. All it means is you give a piece of code the things it needs to work. That's it. So instead of our charge customer function having to magically find its database connection inside some mystery context bag, we just give it the connection directly. No magic. No hiding.
So let's watch how Eleanor refactors Ethan's code. Her goal isn't a clean signature. Not if clean just means short. No, her goal is an honest signature, one that tells you the absolute truth, the whole truth, and nothing but the truth about what her code requires.
And here's how she does it. It's a pretty common pattern. First, she creates a handler struct. This is where she'll hold the shared, long-lived stuff like the database connection and the logger. Then, the charge customer function becomes a method on that struct. And finally, this is key. Any data that's specific to this one request, like the user ID and the amount, gets passed in as a plain old argument.
See? Everything's out in the open. The compiler can see it, it can check it, and it can help you. Okay, so this leaves Ethan with one last really important question. If we're not supposed to use context.withValue for all our dependencies, then why is it even there? What is it actually for?
And the answer is a really simple but really powerful rule you can use. Just ask yourself this one question. Can my function do its main job without this value? For example, can I charge a customer without a database connection? Nope. Can I do it without knowing the user's ID? Definitely not. Well, there's your answer. If the answer is no, then that value does not belong in the context.
And this really gets to the heart of it all. It's about two different kinds of data. On one side, you have your core dependencies. These are the tools your function needs to actually process the request. They're essential. They have to be explicit. But on the other side, you've got request-scoped metadata. This is stuff that's used to observe or route a request, like a trace ID or an auth token. The core business logic doesn't really care about it. That's the stuff that can live in the context.
It all just boils down to this one simple idea. Dependencies are explicit. Metadata is implicit. If you can burn that into your brain, your Go code is going to be so much more robust, so much easier to test, and just honest.
So the next time you're staring at a messy function signature and you're tempted to reach for context.withValue, just stop for a second. Ask yourself, are your function signatures telling the truth? Are you actually making things simpler, or are you just stuffing your problems into a magic bag, setting a trap for your future self? Because at the end of the day, the best code, the truly elegant code, is the code that's honest.